Hello guys, in today's video I will be talking about the first lesson that you likely questioned in high school, primary school, etc. or you are questioning it now, but what are some things useful for or not? And this is the very first video on the channel, so I hope you like and subscribe, but let's begin explaining it. I will provide first the example of why actually how it works. So for example, I'm going to talk about that how powers work in mathematics, for example. This will be the first lesson, powers, where it's potentially useful. And in the other half of the video, or the last section, I don't know how long the video will be, but in the last part I will give an example of how it can be used, that knowledge. So let's get right into it. So first of all, we have powers. But what are they? Well, first of all, let's say that we have a number. We have 2. But it doesn't really say a lot. So what is 2? It's a number. It means, for example, how much of something you have. 1 plus 1 is 2, and so on. But what are powers in comparison? So like, imagine you're a student and learning what powers are. Well, to explain it, basically a power is something like a multiplicative of the same number. Like, for example, 2 times 2 means that 2 is on the power of 4. 2 times 2 times 2 means 2 on the power of 3. This is a calculator way of saying it, the little up arrow. But this is not actually that true, and it can mislead some people, so I'm going to give a little bit more to it, and this is a little bit more. Why? Because a lot of the times people get confused, and for example, let's say 2 times 2 times 2 times 2 is equal to 2 to the power of 2. Then 2 is equal to the power of 1. Then how come that 1 is 2 to the power of 0? It's actually simple because there's always this 1. And suddenly it now makes sense visually, right? Like, that's an easy way to explain how any power on the 0 makes 1, because 1 times not that number is still 1. So like, it still is 1. I'm going to here. That's how it looks like. So what exactly is up with these powers? So like, why is this important? Again, still the mental part. Well, for example, they can be used in binary, which is related to IT, which is a working field where people can use this for several reasons. But let's talk first about what binary is. We have, let's say, 6, 7, 8, and that is 0. Like, I'm just going to delete it because this will make sense anyway, like this. But let's say in binary, these numbers mean 0. These numbers mean 1. Then these numbers mean 2. And can you guess how 3 is written? Can you guess it? Yeah, it's written like this. Why? Your question could be right now that why? Why is it like this? I'm also asking the question for the stuff here, but anyway, I hope no one has OCD here. Uh, uh, this still looks ugly. Okay, so I'm just going to write it out again. So like 0, 1, 2, 3. like this makes no sense. Okay, so what's up with these? How did this whole staircase-like structure suddenly become not a staircase-like structure? That's what one could ask. And it's actually very simple because these numbers are actually powers of 2. So like, imagine it like you have 6, 7, 8. Then each of these numbers, every single one, is a power of 2. So for example, when I say this, it means 2 to the power of 0. When I say this, it means 2 to the power of 1. When I say this, it means 2 to the power of 0 plus 2 to the number of 1. So like, sorry, like this. What about this? If we were to have this, it would mean 2 to the power of 2, which overall would be 1 plus 2 is 3, plus 4 is 7. This is 7. Then, if we put it like this, then this is 8. 2 to the power of 3, you guessed it. And that's basically how it works. So, like, each of these numbers is basically just the power of 2. That's where powers can be useful. But why would you need binary then? Another question that you could very well ask. Well, I'm going to provide you with an example in Python, our very favorite language. Here is a bit of a practical example. For example, let's say we have 5, we have 9, then we have, for example, a print function, print A and print B. Right? So now everything should be ready to be checked. I'm going to make the no, I'm just going to make the CMD appear. I need a second. CMD. And right, we have it. So, let's say that we run this python numbers.py. We run this, and suddenly we get 5 and 6, right? We get these values. So what is up with it? I'm actually going to extend it so it can be seen better, or I don't know, or just put it in here. Yeah, here it can be seen. So anyway, we've got this Python code, and I mean, anyway, I'm just going to leave it here. Let's see, I'm checking. Yeah, it should be enough space. So let's say that we have these two Python values here. It makes perfect sense. It printed out 5 and 9, so like nothing's wrong here. You want to change these two numbers, and you can do it like this, like C equals A, A equals B equals C, and suddenly if you run it again, you get them swapped. Easy as that, right? But what if I told you that there was a forbidden way, and I will explain why it's forbidden, but this works just as well. Sorry, I will fix it. Now it's fixed. So, and this one works too. Why? Why does it work? You're now confused. You're sitting in a chair and completely confused. And I totally get it. And I'm going to show you why it works. Unless you're in IT, because then you probably do know why it works. Probably. You may or may not know. This is actually something that even in IT, some people forget about. It exists. But this can be useful, for example, in networking. So let's talk about it. So what happens here? Well, first of all, let's say that we have the number 5. In binary, it looks like this. Give me a second. 4 plus 1 equals 5, right? Then we have 9. Um, that looks something like this, because 8 2 to the power of 3 plus 2 to the power of 0, 8 plus 1 is 9. So how come that these two numbers get swapped out because of this weird voodoo kind of thing? It's very simple, because this thing in calculator means power, but in programming this means XOR, and you may have no idea what XOR is, so I'm going to explain it, because in, for example, Python, this is power. This is the power in Python, for example. Usually, most languages have their own method power or method above or whatever for powers, because the above cannot be used for powers because it's taken for XOR values. But why are they taken for XOR values? Well, first of all, what is XOR? Well, XOR means that you have two binary data, like, let's say, this and this, and it basically means XORed value, we will just call it that. We will go over every single value. So let's say that these 5 numbers at the back are totally ignored, because XOR checks for actually whether something is true, 1, or false. That's how the OR in XOR comes. But the X means that it doesn't check for if it's both true. So for example, here this one is actually false. So let's check it number by number with XOR. So first of all, each 5 number is false, false, because 0 is false, 0 is false for every single number here. Like 0, 0, 0, 0, and so on. However, from these and this number, these two values do not equal to one another. They are not both false and they are not both true. So they are basically only true on one end. So the XOR value holds up. This is true. These two, however, are true on both sides, which is not a XOR true value. This is XOR false. And then these two again. So it basically means that these two values are kind of like false again. So only this number where one of them was true is true, because XOR works like 1 and 0 means true, 0 and 1 means true, 1 and 1 means false, 0 and 0 means false. That's how you compare those two values, basically. So let's check why it works with our software or little program. First of all, let's see that we have 8. Right? 1 plus 4 is 5 equals 5. Then we have 9. So it changes because of the XOR values to something like this. Then A will be equal, I'm going by the line, A will be equal to 5 XOR 9, which will mean that we go line by line, and up to the first 4 numbers it's 0, then it's 1, so it's 8 so far, then it's 1 again because only one of them is true, then 0, 0. So it's 8 plus 4, which means 12. Now we are going to go with the same, but this time B equals 12 XOR 9, right? Yeah, XOR 9, which means that, for example, we will try to get here that 12, because 9 plus, wait, oh, 8 plus 4, okay, yeah, it's 12. I was like, wait, what? Anyway, so let's go by this comparison then, 12 and 9. So we are going to wait the first four values, those are again false on both ends. Then the fifth value is false as well. Wow. Then the next one is actually true. Then the next one is actually false again. The next one is actually true. And does this remind you of anything? Basically, we could have just copied this, because the two are the same. So wait, now B's value is 5. Now we will, that will mean that we have 12 to the XOR of 5, meaning that we will compare these two values. And let's see, for the first four numbers, it's surely 0 again still. Then for the next one, it's 1. Then for the next one, it's compared, so it is going to be 0. Then it's again 0, but then again compared, it's 1, which will mean 9, because we could have again copied this just as well. And that's basically how these values get swapped out. And that is basically why this only works with numbers, because imagine if the numbers were, well, not numbers, but letters, etc. And they have their own codes, and objects have something similar to, and basically then the whole thing can get messed up. So like, this is basically how it gets swapped out. Now, why can this be important? For example, well, let's say that this can come handy in cryptography as well, but let's say that you have a thing called UDP packet. There is also TCP and FTP and so on, but in today's video we are going to talk about UDP. UDP is mainly used multiplayer games. Let's say that you want to make a video game and you want to make it a multiplayer video game. So like, you log on and you play with your friends, and then you find that out there are a lot of networking protocols. For example, the datagram protocol, UDP. But what does that mean basically? Well, there is TCP first of all, which is kind of like the handshake. Usually a chess game can be wholly written by TCP, but TCP usually is just there to ensure that a connection is made with a handshake. So kind of like, are we talking surely? Yes, we are talking surely. That's what the TCP is for. FTP is for file transfer protocol, and that's unused again unless you want to share files, etc. But you can write that with UDP2 technically, if both the receiver and the sender have the same setup. So UDP is likely the most usable candidate here. So how comes that binary and etc. comes in here? Because when you send a UDP packet, you can send it like U8, S8, U16, S16, U32, S32, U64, S64, and you will have no idea what these values mean until I explain it right now. So first of all, imagine it like seats. Like U8 is a seat for unsigned integers, for example. Let's stick to that, for example, because it's a bit complicated getting into networking, but the idea is that you cannot send larger values than the binary 111, 111, 111, which actually 3, 5, 6, 7, 8, and suddenly there's a 1 because this means 256. If you were to send a number larger than 255, like 256, it doesn't fit into the U8 because the U8 means that you are only sending these values. So if you were to send, for example, a non-U8 packet or something like that, it would likely only process the first 8 values anyway, or something similar. I really don't know even that as well. I usually send them to recipient with the same receiving. But the idea is that when you are using it like this, basically you need to know the range of your numbers. For example, you can build up a packet like it sends one U8, another U8, another U8, then a U64 or an S32. For example, this is how you can write it. Like imagine that you have a game. You want to first send the ID of a player. You know that there are not going to be more than 4 players in your game, so you are going to make it a U8 because let's say 4 is in the U8 range, but um, 60, for example, isn't in the U8 range. So you're confident you can send a U8 for 4 players, U8. Then we talk about, let's say that you want to send again a U8 value, health, let's say. That can be U8 too if the max health is 100 or 100% because that's a thing that a lot of people like to use, 100%, because then if you send out the percentage of a health and it's converted into integer, then it doesn't really matter if it's larger than 100. So like you can have 70,000 health. If you only send 100% of the person's health to the server, it's still going to be 100% of that value. And yeah, it can deal a lot more damage, a lot less, but it won't matter because it has a lot of health anyway and the percentage sent. But then, let's say you want to send the X value of the player. That's where you use the S32. Why? Because let's say that potentially a player can fall out of your map. And there is a negative value for the map as well, for let's say. And they really go far, 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 far. You don't want their game to crash anyway, so like you want to give them the option to leave, probably type in per stuck or anything similar. So you write it in S32, and overall, this will isn't there a way to? Well, okay, it will go like this then. Overall network usage is like, let's say that you used one U8, another U8, so that's for sure two bytes, right? 2 bytes, yeah. And then you use the use on S32. So like, I'm not sure if S32 bytes value, but I imagine it to be like, let's say, mm, U16 is is it 4? Well, anyway, we go with 6 bytes because I don't recall it. This is something you can look up anyway. But the idea is that you can optimize your systems using this by going always to the lowest value you can send to the client. Like, that's basically the best use for it. So when you make multiplayer games, these actually the powers can be useful because then you know how to optimize your game and how to send a packet without it making the system slow down a lot or something similar. Powers can also be useful in many other fields, like for example, uh, let's say that you know about this kind of networking stuff and you know that chemicals usually have a concentration. For example, HCl can have a C for example 0.01 mole as of mole per decimate. I don't know what to call it in English, but anyway, mole per liter maybe. That's for some people more relatable, but usually there are some stuff like that. And apparently, what was it? Is this pH 2, if I recall it correctly? So like for example this. For example, you really don't want to send kind of like a packet like this. Like it's a it's a frac. What is it called in English? Can't remember it. Not native English, but what is it called? Jesus, I cannot remember it. That's the time I think where the tongue, where at the end of the tongue is the word, but you cannot remember it. But fracture, yeah, fracture, I guess. Anyway, fracture of a number, but you don't really want to send that because it's a float value, it's etc. Like, what if you would just send this instead? Like pH. That basically describes the same thing, and meanwhile it can have it's only ever going to be between 1 and 14. Like there are some cases where it's getting weird, like sulfuric acid for chemists and etc. But this usually won't have a number that's below 1 or above 14. Like it's not going to be a case you hear a lot about unless someone is doing a chemistry job regarding those numbers specifically, like again sulfuric acid, where people have a lot of issues with it. But anyway, yeah, this is for example a good example of where you can use this, because you can be certain that the number will never be above 255. You can be certain about that. So like this is one example of where this is useful IRL. Of course, this basically means, for example, you can use it for a personal project. For example, you can make your own file transfer protocol out of this. And let's say you don't want to send it over a kind of thing, you can just write your own file transfer protocol and send it over on the network yourself. Kind of like the manual way of doing things. Kind of like being the handyman at your IT network. Anyway, thanks for watching. Hope you enjoyed the video. Hope it was, well, educational. And see you next time. Take care.